Okay, we said second thing we are going to learn is the log function. Okay, but before we can learn the log functions, we introduced something called composite function, right? Also, we have learned what? Inverse functions. Okay, so we can learn the log function. At the same time, we need to learn, go back to the exponential functions as well. Okay, we need to learn all those things before we can introduce to you the logarithmic functions. Okay, log functions. And so today we are going to talk about exponential functions first, which is on your section 10.2, page 30. All right, so let's talk about what are exponential functions. Take a look, the page 30, okay? So what do you think? What does exponential mean? Okay, so take a look, the page, let's see, 34, this one. On your blank page, blank notes, the page 34, you don't see this. But if you go to the notes with the answer keys, you will find out on the page 34, you can see the example like those. So this one is from the Census Bureau, okay? So it has what? This one for different years and number of the old people over 100 years old, right? So it gets more and more and more. The curve looks like this. So it grows, if it grows gradually like a line, we call it what? Linear growth. But if you grow very sharply at the end, we call it exponential growth. Okay, so we do have a situation like this, and we need to be concerned about it, because if we have more old people, then we need to allocate the funding for that, right, to take care of all the issues. So then let's talk about how we describe the exponential function. Okay, so if I ask you what is an exponential function, how would you describe? Okay, you would describe it is a function f of x. All right, then you have some base, then your x is on your exponential position. Okay, so what does that mean? Let's look at some examples, right? Say y equals, that's your function, f of x equals 2 to the x, or 3 to the x, 4 to the x, even half to the x power. So your x is on the exponential position, then we call it what? Exponential function. Okay, so if your f of x, if it's x squared minus 2x minus 3, so this is a second degree polynomial, so we will call it what? Quadratic function, right? So when x is the base, if your is 2x minus 5, It's a linear function. It's the base. Okay, polynomial functions. But if your x is on the exponential position, then we call it exponential functions. Okay, and the base, the bottom one, the base 2 or 3 or half, okay, usually is we don't use negative number there, we use the positive number. And there is a restriction when you do that. B cannot be 1. That means y equals what? 1 to the x power. We don't do that. Okay, 1 to the any power is always 1. So it's constant function, right? It's no longer a exponential growth. So the base cannot be 1, right? We use the positive number. Then your x is on the exponential position. It's an exponent. Okay? So then if we ask you what is an exponential function, how would you answer? You would say it looks like this. F of x equals b to the x power. B is bigger than 0. B is not equal to 1. X is your exponent. Okay? So then another one, f of x equals e to the x. It's a special e we are going to talk about later. This one is base e. We call it natural exponential function. Okay, let's talk about this later. And let's take a look. The example, if I say f of x equals 3 to the x power, is this an exponential function? Right? If we say g of x equals 2.5 to the x power, can I do that? Right? Or I can do this way. Okay? H of x equals, I can do half, right? As long as it's bigger than 0, not equal to 1. Okay? So to the x. Right? At the same time, you can take a look at this as well. If it's half, is that same thing as a 2 to the negative 1 power? For the power negative exponent, we say it's not negative. It means what? Reciprocal. It's like this. So this one is the same thing as 2 to the negative 1 power. They are the same. Okay, different way of writing. So we might write it this way. M of x equals 7 to the 2x plus 5. Some base, right? Then x is on your exponential position. Then we call them exponential functions. Okay? So we are learning this one right now. Before we talk about the log function. All right. So first, when we introduce them to you, what do? We show you how do they look like. So we visualize first, right? So let's do this one. So f of x equals 2 to the x power. Okay? And if I have this one, g of x is this one, another function. Looks like that. But if I write 2, okay, to the negative x power, instead of write regular x, you have a negative number here, negative, okay? So it's that same thing as half to the x power. See, they are the same. Half means what? 2 to the negative 1 power. So we are going to graph them and to show you what happens if the power is x, regular x? What happens if the power is negative x? Let's compare them. Okay, visualize them first. So, let's take a look. Right? So I'm going to make a little bit bigger. Okay, let's do 2 to the x power. So what should we do? Always do your t-table. Okay? So what kind of numbers we can put in x for the exponents? Right? 2 to the 1 power, 2 to the 2 power, 2 to the negative 1 power, or 0, or negative 1, negative 2. Can we do that? Powers can be positive or negative or 0, right? So if it can be positive or negative, then we usually put the 0 in the middle. Okay? So, put the 0 in the middle and see what happened. 1 and 2 and negative 1, negative 2. So 2 to the 0 power is 1, 2 to the 1 power is 2, 2 to the power is 4, 2 to the negative 1 power is reciprocal, right? 1/2. 2 to the negative 2 power is what? 1 over 2 to the second power is 1/4. Is that right? Okay. If it's a negative, then let's see. We still use x and y. Y equals what? 2 to the negative power. It's 2 to the negative power, right? So we put the 0 in the middle, same thing. Then we just use different numbers for that. Same numbers here, right? So 2 to the negative 0 is what? 2 to the 0 power is 1. 2x is 1. Then you have negative, become negative 1. It becomes half. 2 to the 2 power with negative will be 1 over 2 to the second power is 1/4, right? 2 to the negative x is negative 1. It ends up 2 to the 1 power is 2. 2 to the negative of negative 2 will be 2 to the 2 power will be 4. Right? What's the difference? This is 1/4, 1/4, half and quarter. So it's kind of with different signs, right? Opposite. So let's graph it, then see what will happen. So 2 to the 0 power is 0, 1. Okay? 2 to the 1 power, x is 1, y is 2, x is 2, 1, 2, 3, 4, it's 4. Okay? Negative 1, x is negative 1, it will be half. Negative 2 would be what? Quarter. So then the graph will look like this. It goes up quickly, right? However, if you have 2 to the negative 100 power will be what? 1 to the 100 power. It's a very tiny number, right? But it's still what? Positive. So if your y equals x equals to negative 100, okay, even say negative 1,000, so x is down to the 1,000, negative 1,000 over there, it's 1 to the 1,000, right? 2 to the 1,000th power, so it's very tiny, but it's still a positive number. So what will happen to the curve? The bigger one, the x is positive, it goes up quickly, right? But you will still go up all the way. But here, you will go, become tiny, but always positive. Can it be 0? Not really. If 2 to the, say, 10,000 number, still a positive. So you will approach to the 0, but can never be 0. Okay? So that would be 2 to the x power. So, right, this is just a basic concept. And for your test, of course, we will ask you to visualize it and show 2 to the x power, 3 to the x power, 4 to the x power. Right? You should be able to graph it by the t-table. Right? How about this one? If it's a negative power, so what do we have? x0, y is still 1, x is 1 instead of going up, but it's what? Becomes half. Then 2 to the x is 2, y is what? Quarter. Okay, getting smaller and smaller. Then if it's a negative 1, actually it's 2. It's a negative 2, because negative power become positive, is 4. Okay? So it turned out is what? Like this. This one is getting smaller, but never touch this line. Right? So they are close, getting closer to this line. This is your what? X-axis, right? X-axis. So means what? Y equals 0. That's this line. Y equals 0, y equals 1, y equals 2. That's your horizontal lines, right? So we are checking the exponential functions. How do they look like? Okay, so this one is what? Exponential growth. We call this one is growth. Then this one is what? Decay. For the shapes like those, right? We also figure out what kind of characteristics they might have. Okay, so for usually we use what? B as a base. Take a look. This one base is what? 2. This one, if you just use x as exponent, then your base is what? Half. Okay? So, if I have f of x like this, b to the x power, if my b is bigger than 1, so my graph will look like this. Okay? If I have f of x is b to the x, if still x, not a negative x, but it can be what? If b is between 0 and 1, means half and third, things like that. Half and third, you can change the exponent, become negative. Actually, it will be this graph for the exponential decay. Right? So, let's find out their characteristics for those. So what's your domain? For functions, we always talk about domains and ranges, right? So domain for this one, the black one, for x, or real number. What happened to the range? See, what's your y? How far you can go up and down? It's stopped by this line, right? So the range will be, but it can never be 0. 1 over some numbers, always positive, okay? So 0 to infinity. So that's your y, okay? So let's take a look at the function. Then is this a function? Yes. Is this a one-to-one function with the horizontal line test? Yeah, one-to-one, yes. Okay, so if you have it's a one-to-one function, then does it have an inverse function? Yes. Okay, then we also care about something y-intercept, x-intercept, right? So for this one, what's your y-intercept? Right here, right? 0, 1. Do you have an x-intercept? You never touch this line, x-axis, right? So it's none. Okay, then another thing we are going to learn is the characteristics of the curve can never touch this line. Okay, it's bounded and limited by x-axis. Okay, and which is horizontal as well. Then, so we call it what? Horizontal asymptote. What does asymptote mean is the boundary line, it approaches but never touches. Okay, so horizontal asymptote, this line is what? Y equals 0. Okay, so what does that mean? So you can see as what? As x getting bigger, it goes bigger, but when x is getting smaller, when x is approaching to small number, right? Like -1,000, -10,000, it goes very small, go there, and but the y is approaching to 0, getting closer to 0. Okay, horizontal asymptote. So you need this concept for your pre-calculus and calculus. You don't need this for business calc. Okay? Then this is what? Just a basic 2 to the x power exponential growth. Let's look at the characteristic of the exponential decay. Okay, so like a negative, when your power is negative, that means things will kind of drop, right? It's like your depreciation instead of your, increase in value of your real estate. Maybe it's depreciated like those. So, okay, so what's your domain? Domain will be the same. Then what's your range? Will be the same, right? Y is all the way from here. So, is that 1-to-1? Yes. Does it have inverse? Yes, if it's a 1-to-1 function, right? So what's the y-intercept? Y-intercept still 0, 1. Then, does it have a x-intercept? No, none. All right, it's the same thing. It has what? Horizontal asymptote, y equals 0, okay? Then the situation is as x approach to infinity this way, right? X is bigger and bigger and bigger, then your y becomes smaller and smaller, approach to 0 this way. Okay? So, what do we just talk about? To visualize the exponential function, right? Either growth or decay with certain characteristics, okay? So most of the time, we just do the growth. So let's see, if we want to do this one, if my f of x is 2 to the x, g of x is 3 to the x, h of x equals 4 to the x, and mx equals e to the sum x. How does it look like? Okay, that would be very similar to those. If you graph it, okay, so let's do the 2 to the x again. Here, and 2 would be 4, -1 would be half, -2 would be quarter, so that would be your what? 2 to the x, right? Then let's do 3 to the x. So you do your t-table, right? So x is 0, 3 to the 0 is still 1, x is 1, then would be what? 3, right? 3 to the 1 power 2, instead of 4, it would be 9, okay? Then x is -1, then 3 to the -1 power is 1 to the 3 to the 1 power, 1/3. So it would be here, then we are doing this, right? 3 to the x power. Then 2 would be 1/9, so getting smaller faster and getting bigger faster as well. So it will look like this, right? So you continue go, you will continue go, but never touch the horizontal asymptote, right? This is a horizontal asymptote, x-axis, which is a line y equals 0, right? Okay, then let's take a look. 4 to the x power. If 4 to the x power, you do your t-table, still same. So 4 to the 1, 0 power is 1. 4 to the 1 power is what? 4. 4 to the power is what? 17, right? Then -1 power, 4 to the -1 power is 1/4. It's 1/4. Smaller is smaller, 1/16. So you will look like here and shoot up, right? So that would be 4 to the x power. Okay. This is 3 to the x power. All right. And you are going to learn something called E. If you use your calculator, and you will find out there is something called the E, right? Try to use the calculator to see the E, right? Then sometimes it gives you this. That means power. Then if for the E, you want to find out the value of E, you do E to the 1 power. Okay, you will get a value like this, 2.71828, some kind of number. All right, and we are going to use this E quite often later on to solve problems. So where's the line, where's the graph for E to the x power for this one? E to the x power. Because E is what? 2.71 something. That means what? Between 2 and 3, right? So your curve would be what? between which line? Between the 2 and 3, between the black and the blue. So your e to the power somewhere there. So that would be in between, things like that. Okay, got an idea? So you need to practice your calculators. I cannot show you, it's hard to show you, right? And it takes forever. And you better know how to do it. Either you go to tutoring center, library tutoring center, they can show you, or you go to the internet website, then they can show you. You practice that. So if you want to find e, what is e to the second power? You use calculator like this. Then what kind of number you should have? It's about 738,905. Okay, e to the q would be, practice that. If you have a problem, then call me, then I can explain to you, and over the phone we can go through the Zoom, then I can show you, right? Okay? If we have things like this, if we have things like, if I have a function, n of x is this one, okay? 3x minus 2. It's like your quadratic function, right? You have quadratic function is what? We use a vertex form, right? If we have this one, then x is moved left and right, opposite direction of the number k. Outside of x, it's k go with what? Not x would be with y. It goes up and down, right? So if it's like this one, what should we have? Okay, if you plug in your numbers, okay, so if you have x, y equals what? 3x minus 2. Same thing, you put a 0 in the middle, 1, 2, negative 1, negative 2, right? 3 to the 0 is 3 to the 0 minus 2, 3 to the 1 minus 2, right? So instead of what? 1 minus 2 become negative 1, that's 1, 4, 9 would be 7, right? 3x. But instead of there, you have what? Negative 1. Okay? Then instead of 4, you have what? 1. So here, it gets smaller and smaller. Okay? So instead of 3 to the negative 1 minus 2 is 1/3 minus 2 is what? Negative 1 2/3, right? So you have 2 here. So instead it's negative 1 to negative 1 2/3 right here. Okay? Then this one will be negative 2. Will be negative 2 minus 2 is 1/9 minus 2 is what? Negative 1 8/9. Right? So it's getting smaller and smaller. Okay? Go down like this. So it goes like here. Okay? But it's limited by this line. Okay? When you minus 2. So what happened? It's like a 3x, right? But it shifts down 2 units. Everything, the blue line to here. But you will, like this one, never touch this 0. So you will never touch what? shift down 2. So this line is what? Y equals -2. So it has what? Horizontal asymptote. You need this concept for your pre-calc. Okay, horizontal asymptote. What's your equation for that? That would be what? Y equals -2. Okay, so we look at more examples for the exponential functions with different bases, right? 2, 3, 4, even the e. Okay, so we are learning exponential functions. Then first we visualize it, and we are going to solve. Next one we are going to learn is to solve the exponential equations, right? Usually we find out what do they look like, what do they mean, then we solve equations, then we solve word problems, right? Okay, so let's look at some exponential equations. And if I have say 5 to the x power equals 5 to the, say, third power, what do you think? What's your x? Do I have exponential things, right, with equation? So we have exponential equation. So if you have the same base, you can just ignore those, then x is 3. That's how we solve it, right? Okay, so let's take a look. The page 31, and how do we solve it? So if I have Bm equals Bn, all right, same base, and of course for the base we use bigger than 0, we don't use 1. Okay, so it means what? You can ignore that, then your power would be the same. So we are going to use this characteristic and the property to solve our exponential equation. Okay? Let's see. I'm just checking my pages. All right. Okay, here we are. Okay, so we are on the page 31, right? So if you have first one, 2 to the x minus 1 to the 16, what do you think your x should be? 2 to the some power is 16. So let's just guess. X is what? If it's 5, 5 minus 1 is 4, to the 4 power is 16, right? But how are we going to solve it? Systematically, so we can solve all the problems, right? Not just by guessing or easy one you can guess. So what do we do? Okay, see, we have to make the base the same so we can use the property. So if I make a 16, it's 2 to the 4th power. Can we do that? So you just do your trees, right? Find out how many 2's there are. So if so, what do we have? X minus 1 is 4, linear equation, so x is 5. That's how you do it. Okay? So, take a look. If I have 125, x to the plus 1 equals 25 to the 2x. That's very hard to guess, right? But take a look. what kind of things can go into 1, 2, 5? If you do the trees, 5, 25, so it's all 5, right? So it's 5 to the third power to the x plus 1. Then 25 is what? 5 to the square to the 2x. Is that right? So, how can we make the base the same? We can use 5. But remember, how should you apply power on power? We are talking about exponential functions, all about the exponents, right? So it has to use the property for the power thing. So remember, we'll keep repeating this before. In your 152A and 152B class. So if you times it, how many powers for the base A? You add them, right? So product property. But if you have power on power, how many A's? You multiply them, right? If you have M, if you do division, quotient property, you minus them, right? So what do we have? This power on power. So you have 5, 3 times what? X plus 1. Here is 5, 2 times 2x. Now we have the same base, so we can ignore them. So you have what? This. Then 3x plus 3 equals 4x. Then what's your x? Right? You solve it, then that would be 3. So what do we have here? So I have 125 to the 3 plus 1 is 4. It's the same thing, 25. 2 times 3 is 6. They are the same. You can even use the calculator to do 125 to the 4th power, get a number, and 25 to the 6th power, get a number. You can verify them that way. Actually, they are the same, right? Okay, so what are we doing? We are solving exponential equations. Okay, so what's the method? If we can make the base the same, we can use the property to compare the exponents, then we can find the answer for x, right? So for 1/9 and this, what do you think? Which base you should use to make them the same? 1/9, you have 3 there, right? So this is what? 3 squared. So, but you don't want to use fraction as your base. It gets complicated. So you can change this to what? 3 to the -2 power. Can you do that? 1 to the 1, 3 to the 2nd is 1/9. So you have 3, 4x plus 3. So what do we have? So you have -2 equals 4x plus 3. Then you minus 3. So 4x is -5. What's your x? Divided by 4. -5/4. So that would be your answer. So sometimes your answer is what? A fraction. Okay? Look, next one. Take a look at that. What do you think? Which base is possible for you to use? 8. Which number can go into 8? And which number can go into 16? So 8 is what? 2 to the 3rd power, right? So 16 is what? 2 to the 4th power, right? Then you use a power property, power on power, that would be what? 3 times 2x minus 1. This is 4 times 3x. Then what do we have? Same base, we can use what? 6x minus 3 equals 12x. Then you will solve it. Minus 6x. So negative 3 is 6x. And divided by 6, x is what? Negative half. Right? Are we good? So we are learning exponential functions, how they look like. When you graph, it will be exponential growth or exponential decay, right? Then we are learning the solving exponential equation. Okay, if they have same base, you can just compare the power. So if you have this one, can you make the base the same? 6 is 6, 7 is 7. You cannot make the same, right? You cannot make the base same way, all right? Then what? We will do it later. So that's why we are going to learn the log. Log can help you to solve the exponential equations as well. Okay? Okay, let's do some apps. We are on the page 32. First one, Chris is a researcher at the Center for Disease Control and Prevention, and he is trying to understand the behavior of a new and dangerous virus. He started his experiment with hundreds of the virus that grows at a rate of 25% per hour. Okay, he will check on the virus in 24 hours. How many viruses will he find? Okay, the number of the virus present at the time t is given by the formula. So you have a formula looks like this. A is your amount. Okay, A sub 0 means what? At the beginning of the time 0, and e to the RT. So when you have situation like this, A0, it says is original amount at the beginning of time, right? R is the rate. So where's your variable? So you need to identify your variable first. The amount grows according to the time, right? 25% every hour. So the time is your variable. Okay? According to this one is what? By the hour. Right? So we want to find out after how long, in 24 hours, how many viruses there are. So how should we use this formula to do it? So it says A0 at the beginning of time, it has what? 100 to start with. So your A0 is 100. Right, your R is your rate. It's what? 25% per hour. So what you want to do is change percentage to the decimal. Okay? R is the rate. Time is how much time we have? Say 24 hours. So how do you write your equation. So your amount is supposed to be A0 would be 100, right? E, what's your R? 0.25. What's your T? 24 hours. So you plug in that, okay? And you better know how to use the calculator to do those, okay? And you should get 40342 somewhere, right? Then we round it to the whole number, so it should be about 40,343 viruses. Good? That's how we apply the exponential variable to the situation, right? Let's look at the second one is radioactive decay. The number of grams of a certain radioactive substance presented at the time t. So time t is your variable, right? It's given by the formula like this. A equals 300 times e to the negative 20.06 t. And t is the years, okay? So some material will decay. See, your exponential function for the exponent is negative. You will have a decay, right? It says first find the time t equals 0. Then another one is time 20 years. Then use this graph to estimate number of years it would take for half of the substance to decay. Then D, will the substance ever decay completely? Okay, so the first one, we are going to find the amount present at the time t. So t equals 0. What do? So you just plug in 300 e to the negative 0.06, 0, right? E to the any 0 number is what? 1 times 300. So you should have 300 of what? Grams of substance at the beginning. That's what it tells you, this formula, right? Second one, it says find the amount present after 20 years. So t is 20 years. So what do? You just plug in, right? E to the negative 0.06, 20. Then you should get 90 grams. Make sure you know how to use your calculators, right? Then third one, use the graph to find when it gets to half. So you start from 300, half would be what? 150. So you look at the 150, right? Then find your years for the x, okay? So per graph, so what should we have? It should about 11.5 years for half of it is 150 grams. So we are looking at, right? Then next one, and will the substance ever decay completely? We say it will go, right? Smaller and smaller, but it will never touch the 0 line. So it becomes very tiny, and it's almost like none at the end, right? But technically, it's no. You will never get to the 0 position. Okay? let's look next page, page 33. There is a new formula for you, okay? Here say amount equals P times 1 plus R to the N to the NT. This is the formula for periodic compounding, okay? So, if you pay your credit card, it charge you, you know, say, monthly, they charge you, say, 1 year, they charge you 6%. Then monthly will be what? Divided by 12.5%. So how much it will charge you per month, right? So usually they will give you R would be what? The annual rate. Okay? Then P is your principal. Then A would be the total amount, right? A would be the amount. So the N, what is N? N is the number of time interest is compounded per year. What does that mean? Okay, if you compound monthly, that will be 12 times per year, okay? If it's a monthly, that will be 12 times per year, right? If you compound quarterly, that will be what? 4 times per year, right? If you compound semi-annually, that will be what? Twice per year. Is that right? So N will be those numbers. If you compound daily, that will be what? 365 times per year. Okay? Then T will be used as year. So this is a function. P will be given, right? Our annual rate will be given. How many times per year will be given? N will be given. So which one is the variable will vary? It's how many years you will compound the money. Okay? So your variable is at the exponential position. So it's exponential function. All right? And how we are going to use that? Solve, look at the number 3. Solve using the formula above to find the amount owed at the end of 5 years. If you borrow $3,000 at the rate of 10% per year and compound quarterly, then 5 years later, how much you owe them, right? So you want to find the A, but how much you borrow? You say $3,000, right? What's your rate? It says 10% per year, so that would be 0.1. Compound what? Quarterly. Quarterly means 4 times per year, so N is 4, right? Then for how long? It says 5 years. Then what do you need to do to find your A? You plug in. A equals 3,000. 1 plus R is what? 0.1. 4 divided by 4. 4 times per year. So each time you just add a little bit, right? Then times NT. 4 times T is 5. Why the formula is this way? You will learn in the either pre-cal or business calculus type of things. Okay, the reason behind it. Then this portion we are talking about algebra is high school algebra, so we didn't explain why, how you get this formula. You just plug in, see if you can find the answer first. So you do that, and you need to, how do you do that? You just use calculator if you can type in the whole thing correctly, right? So you will do what? 3,000 times, right? So you do 1 plus 0.1 divided by 4 to the power of what? 20. You would do the power first, then do the multiplication. If you are not sure, you put another parenthesis. Or you can just do from inside to outside. So you do this first, 0.1 divided by 4, hit the enter key, plus 1, hit the enter key, then take a 20 power on it, hit the enter key again, times 3,000. Okay? Then you use all the decimals, then round at the end, because it's money, so you automatically round it to the second place. And it's for $1. Okay, make sure you practice punching in the calculator, you get a correct answer. Okay? Because when we go back to school, then for the next class, you need to show how you use the calculator. If you have problem, call me. Next one. Outstanding performance. The top growth fund at Fidelity Investment from 1992 to year 2000. That was good time, right? Internet boom time. So was the low price stock fund, which returned an average of 18.21%. That's really nice. For 10 years. We wish. Okay? Now if it's not negative. But at that time, it was booming time. So if an investment, $10,000 was made in this fund during that time, what was it worth at even year 2002? So if you start from $10,000, so you use this formula, right? P is what? $10,000 you put in, then 1 plus, what's your R? 18.21. So it's 0.1821. So if you compound annually, right, for investment, so you divide it by N is 1, is 1 times T for how long? Between these two, for 10 years. So during that time, if you invest $10,000, okay, during 1992, then 10 years later, how much money you have? Then you do the calculation, is what? 53,277.30. You round it at the end. You have $53,000. From $10,000 to $53,000, and for 10 years. That's really high yield. Okay? So that's how we use the exponential variable to do the apps. Good? You should be able to handle this. Okay? So exponential functions are not your problem. The log will be your problem. So we will find out soon. So that will cover our section 10.2.